Alright, so here's the general form of a quadratic equation. And basically we're going to analyze this graph. So I'm going to ask you to graph this, and then I'm going to ask you a bunch of questions like where is it increasing, where is it decreasing, what's the sign, what are the zeros, what's the maximum or minimum value. So I'm going to ask you all these things. But before we can do any of that, we have to first find the graph. Now the best way to get the graph is to put the point, the vertex point on, so we know where we're starting from. Now, in standard form, the vertex point was h and k. So standard form looked like this: y equals a x minus h squared plus k. Now, from here you can see h and k was your vertex. From the general form, you don't have that h and k. So what you're going to need to do is convert the general form equation into standard form. Now, I'm going to erase this to make room, and then I'm going to show you how to convert from general to standard. Alright, so the h value, so actually before we even get to the h value, the a value in y equals a x minus h squared plus k, the a value is the same as the a value over here, and we see that it's 1. So I have y equals 1 bracket x minus something squared plus something. Okay, so that something is h, and h we get it by the formula h equals minus b divided by 2 times a. Now I can see over here that my b is positive 6, and I can see over here that my a is positive 1. So when I replace it into this formula, I get minus 6 divided by 2 times a is 2. So here I've got h equals minus 3. Great, so let's plug in h equals minus 3. So in my formula I have x minus h, but my h is already negative, so what I have is minus 3, and that becomes plus 3. Now to find k, to find the value of k, what you do is you plug in the value of h into your equation, into your y, into your x of your general form. So k is equal to minus 3 squared. Remember, I'm plugging it into here and here. So minus 3 squared plus 6 times minus 3 plus 8. Now what does that give us? It gives us 9 plus 6 times minus 3 is minus 18. So minus 18 plus 8. So what does that give us? It gives us minus 1. So my h and k are minus 3 and minus 1. So let's start graphing this. So here's a sketch. At minus 3, minus 1, I'm over here. This is my vertex, minus 3 and minus 1. Now, I have to ask myself, is this going up or down? And I can see from the general form here, or from the standard form, that my a value is positive, so it's going to go up. And on top of that, from the general form over here, I see that my y-intercept is positive 8. So let's go here, let's plug in the positive 8 here. And I also know it opens up, so it does something like this. Great, so I could expect to have 2 zeros. Now, let's try to find those 2 zeros. So I can either use the quadratic equation, which was minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Those will give me my 2 zeros. Or I can factor it and put it into the zeros form. I can factor the equation. The equation was y equals x squared plus 6x plus 8. So I can factor it, and in fact when I do factor it using the method of my choice, what I get is y equals x minus, x plus 2 times x plus 4. So I can see here that my 2 zeros are minus 2, so minus 4 and minus 2. So I've pretty much gotten all the important points of this parabola, of this quadratic equation, and now I'm going to ask you for the domain. So the domain, which I'll call D, is all the real numbers, so R. And that's because all the possible values of x are all these over here. All of them. They all fit in my equation. There's no restrictions. My range, however, I'll call it R. My range has a limit. So it goes all the way to infinity, but it stops here at this value over there. And what's that value? That's the value -1. So the range is y is an element of -1 all the way to positive infinity. So you can always see that the maximum or the minimum will be the k value of your standard function, of your vertex. Now, when is this function decreasing? So I'm going to call this function f of x, and I'm going to ask you, when is it going down? When is it decreasing? And this happens for which values of x? For which domain? Well, let's take a look at our graph, and we see that it's going down, it's decreasing all over here. So what does that mean? It means that all these values here of x are the values where this function is decreasing. So what is that? That is x belongs to -infinity all the way to -3, including -3. What if I asked you, when is this function f of x increasing? That would be for which values of x? Well, if we look over here, our function is increasing. So this is from this point here all the way till infinity. And that means x belongs to, it's increasing from -3 all the way to positive infinity. Now what about the sign of this graph? So the sign of this graph basically means, when is this positive or negative? So let's see, when is f of x, when is our function f of x greater than or equal to 0? So above or on the x-axis. Well, this happens all over here and all over here. So for these two parts over here, it's positive. That means I look at my zeros and I say x belongs to -infinity to -4, including -4 because it's on the x-axis, union -2 all the way to positive infinity. And our function f of x is strictly less than 0, so below 0, below the x-axis. This happens for the values of x when x is inside -4 to -2, not including them. Because if I include them, then that means I include the 0, and I don't want to. Alright, and now where is the maximum or the minimum? Well, if I look at my graph, I see that it opens upwards, and therefore it has a minimum point. So it has a minimum. Minimum, min, is y equals minus 1, the k value. And that's pretty much it. That's pretty much the entire analysis of this quadratic equation.